This first lesson is on density. So you did a lab. You asked, how does the mass of a collection of wooden objects depend on the volume? So you found the volume and plotted it on the x-axis and the mass on the y-axis. And I think you got a pretty straight line. In this case, it makes sense to treat the intercept as 0 because a volume of 0 would lead to a mass of 0. If you had a block of wood and its volume was 0, the mass would be 0. So we can say that the mass is directly proportional to the volume. The slope we are going to identify as the density. Okay? So the density you can think of as the slope of the mass versus volume graph. We're going to use the Greek letter rho for density. Sometimes in chemistry you use d, but in physics we use a rho. And you can think of density as the ratio of the mass divided by the volume. Something that has a lot of matter stuck in a very small amount of volume would have a very large density, like gold or lead or uranium or platinum. Those all have high densities. On the other hand, if the mass was pretty small, there just wasn't a whole lot of matter, and it was spread out over lots of volume, we would have a very small density. So think styrofoam or maybe air. Okay? The standard units of density will be a unit of mass divided by a unit of volume. So that's going to be grams per centimeter cubed sometimes and kilograms per meter cubed other times. Those are the two standard units of density. Water has an interesting density. It's actually rigged. In the SI system, the gram was actually defined as 1 cubic centimeters worth of water, the mass in that cubic centimeters worth of water. So if you have 1 cubic centimeter of water, it's the amount of matter contained in there is defined as the gram. So that's kind of handy. The density of water is 1. And so it's easy to compare densities to the density of water because water is 1. If you have 1 centimeter and you think about what happens if you take 10 centimeters, so 10 centimeters by 10 centimeters by 10 centimeters, that cube would be 1,000 cubic centimeters. And a cubic centimeter, this little cubic centimeter here, is also called a milliliter. So 1,000 milliliters is actually 1 liter. So 1 liter of volume is what you get when you have 1 kilogram of water, okay, or 1,000 grams. So 1,000 grams is a kilogram. So the mass of 1 kilogram of water, the volume of 1 kilogram of water is 1 liter. So a 2-liter bottle contains 2 kilograms of water. Sometimes we have to convert back and forth from grams per centimeter cubed to kilograms per meter cubed. So if you take grams per centimeter cubed, we're going to get rid of the grams. So we have 1 kilogram is 1,000 grams, and the grams are in the numerator here and the denominator there, so they cancel. And then I've got centimeters cubed here, so I need centimeters in the top and meters in the bottom. But since this is cubed, I've got to cube the conversion factor, and so the centimeters cancel. And it turns out you get 1,000 kilograms per meter cubed. So if you have a cubic meter of water, its mass is 1,000 kilograms, which is also called a metric ton. For the most part, we are not going to need to know any densities except water. And so if you ever need to know the density of anything else, you're just going to look it up in a table. So this is the table you're going to have access to on your homework. Just be careful. If the problem's in kilograms and meters cubed, this density is in kilograms per meter cubed. This density is in grams per centimeter cubed, and you will just use whatever one you need for the problem you're solving. Notice they're connected. If you take this number here and multiply it by 1,000, you get how many kilograms per meter cubed. And you can see that uranium, platinum, gold all have very high densities. They're actually a lot higher than lead. Lead is 11. Gold is 19 kilograms, 19 grams per centimeter cubed. And then you can see some other things down here, pretty low densities. These are typically gases. So here's an example problem that you might have to solve. What if you have a cube of aluminum? So here's my aluminum cube, and it has a mass of 100 grams. I want to know what is the length of the edge of the cube. So since this is in grams and this is in centimeters, I'm going to get the density in grams per centimeter cubed. It's 2.7 from the table. I know the mass is 100 grams, and I've got to find the length. So step one, I'm going to solve the density equation for the volume. Here the volume is in the denominator, so I would multiply both sides by V first, and then divide both sides by rho, and that would give me the volume is the mass divided by the density. The second thing I'm going to do is for a cube, the volume is the length of the edge cubed. So I've got to solve this for L. So if the volume is equal to L cubed, then L equals the cube root of the volume. Since the volume is m over rho, I'm going to go ahead and stick that in. So what I really need to do is take the cube root of m over rho. The mass is 100 grams. The density is 2.7 grams per centimeter cubed. And when I take the cube root of that, I get 3.3 centimeters. So a cube, 3.3 centimeters on edge of aluminum would have a mass of 100 grams. So that's an example of a problem you're going to solve. Okay, so today's assignment is to solve some fairly simple problems involving density. The ones at the end just get a little trickier because you have to be able to find the volume of some common geometric solids. So if you have any trouble figuring out the volume, for example, of a cylinder, you can just Google it and use the formula there. All right? Okay, good luck.